Alright, hello everybody. Today we are starting off with Chapter 9, Quadratic Functions. So 9.1, we are identifying quadratic functions. So a quadratic function is of the form y equals ax squared plus bx plus c. Alright, but the most important thing about this is the x squared. Alright, that's what makes it a quadratic. The graph of a quadratic function is a curved called a parabola. Alright, so parabolas can open upwards or downwards, but they always have the same basic U shape. So if you hear us say U-shaped curve, we are talking about a parabola. Alright, now there's a very important point on each parabola. It's either at the very top or the very bottom of the parabola. It's called a minimum or a maximum. It is also called the vertex. You can think of that like the branching point of where the graph starts. So let's start off with y equals x squared. Alright, so in my table I have a bunch of x values. So to find my y values, I just need to square them. So negative 2 squared is 4. Negative 1 squared is 1. 0 squared is 0. 1 squared, 1 times 1 is 1. And 2 squared, 2 times 2 is 4. So I'm going to go ahead and graph all of these ordered pairs. So negative 2, comma 4. Negative 1, comma 1. 0, 0. 1, 1. And 2, 4. Alright, and we can connect them with a smooth line. And you can see our U-shaped graph. Alright, so this one opens up because the arrows are pointing up, and our vertex is at the origin, so 0, 0. Alright, let's try another one. Alright, this second one's a little bit more confusing. So we have y equals negative x squared plus 4x, but the negative's not in parentheses, so it's negative on the outside. And if I plug negative 1 in, square plus 4 times negative 1. This actually gets me, negative 1 squared is positive 1, but then I still multiply that negative on the outside, so I still end up with negative 1 minus 4 to give me negative 5. If I plug 0 in for x, 0 squared plus 4 times 0 is 0. Negative 1 squared plus 4 times 1 is going to be a negative 1 plus 4. So that would give us 3. If I plug 2 in for x, I have negative parentheses 2 squared plus 4 times 2. So this would give me negative 4 plus 8. And lastly, if I plug 4 in, I get 16 with the negative, so negative 16 plus 16 equals 0. Alright, so let's graph these points. Negative 1, negative 5. 0, 0. 1, 3. 2, 4. And 4, 0. Alright, so now we can make our graph. And we can see that this graph actually opens down. And this time our vertex isn't at 0, 0. We want to look at where the graph starts, so that would be at 2, 4. So what makes a graph open up or down? Well, we need to go back and look at our x term. If it's a negative x squared, then it's opening down. If it's a positive x squared, it's opening up. Alright, so with linear functions, you might remember that every time you increase the x, the y value also increases by the same amount, and it's consistent all the way through. Quadratic functions, however, have a curved graph, and so it's not like linear where they do not have constant change from one number to the next. However, there is a pattern in what we call the second difference. So what the second difference is saying is as you increase your x values by 1, or at a constant rate, we need to look at the y values. So the first difference is, in this example, we see from 0, 1, 4, 9, 16, the first differences go up by 1, up by 3, up by 5, up by 7. Now, if all the first differences were the same, it would be a linear function. Since they're not the same, let's check the second difference. So find the difference of those differences, and you can see we're increasing by 2 each time. So because it's the second difference, we know our power is raised to the second power, or in other words, it's a quadratic. So now let's do some practice. All right, I will do the first 2 of the equation, and then the first 2 of the table, and the others are for you to complete. So on this first one, I have y plus 6x equals negative 14. Now I don't need to get y by itself. I would just need to subtract 6x from both sides. So I would get y equals negative 6x minus 14. But I know that this is not a quadratic. My explanation is because there's no x squared term. All right? Just an x makes it linear, which means it's a straight line. Right? And that goes back to chapter 5, I believe. Number 2, the second one, we have 2x squared plus 3x minus 1. Now right away, I see x squared. So that tells me quadratic, all right? Because I have the x squared term as my highest exponent, that tells me it's quadratic. All right, so I'm jumping down to the table problems now. All right, at the very end, you can check all of your answers with mine to make sure we did them correctly. All right, so this first one, I look at my x values and I see that they're increasing by 1 each time. Even though the numbers are going down, remember since they're negative, they're still technically going up. All right, we're adding 1 each time. Maybe I could say, whoops, plus 1, plus 1, plus 1, plus 1. All right, but we don't need to look at our x differences once it's consistent. All right, we need to look at the y values. From 39 to 18, we went down, so negative 21. From 18 to 3, we went down 15. From 3 to negative 6, we went down negative 9. And from negative 6 to negative 9, we went down negative 3. So that's our first difference. And since they're not the same, we know it's not linear. So let's look at the second difference. From negative 21 to negative 15, you go up 6. From negative 15 to negative 9, we go up 6. From negative 9 to negative 3, we go up 6. All right, so our second difference is all the same. All right, that tells me it is a quadratic. So it is a quadratic because the second difference is the same. All right, so let's do one more. The one below it. From negative 2 to negative 1, we went up 1, up 1, up 1, up 1. So all of our x values are increasing by the same amount. So that's a good place to start. From negative 1 to 0, we went up 1. From 0 to 4, we went up 3. From 4 to 9, we went up 5. And from 9 to 15, we went up 6. All right, so that's our first difference. So let's take a look at our second difference. From 1 to 3, we went up 2. 3 to 5 we went up 2. 5 to 6 we only went up 1. All right, so plus 2 plus 2 plus 1 is not the same. So it is not a quadratic because the second difference is not the same throughout. It is not consistent. All right, so go ahead and pause the video. Then when you're done, come back and check to see if you have the same answers that I do. All right, so here are all your correct answers. Feel free to pause it, check them, make sure you're doing all right, and then get started on the practice and the LT check.